So thank you, everybody, and good afternoon. Welcome to what is the inaugural CAPLA lecture of our spring semester lecture series. My name is Beth Weinstein, and I'm an associate professor at the School of Architecture, and I serve as the School of Architecture Events Committee chair, along with faculty members Susanna Dickinson, Oscar Lopez, and Teresa Rosano, as well as student members of the committee, Nicholas Altamura, Jasmine Guzman, Alfredo Quesada, and Amy Yang. The CAPLA AIA talk series includes events sponsored by both the AIA of Southern Arizona and the two schools comprising CAPLA, or the College of Architecture, Planning, and Landscape Architecture at the University of Arizona. The University of Arizona occupies and is built on the original homelands of indigenous peoples who have stewarded this land since time immemorial, and we're honored to work on the traditional lands of the Tohono Nation and Pascua Yaqui tribe. And on behalf of the College of Architecture, Planning, and Landscape Architecture, I pay my respects to these communities and to their elders past and present. Aligning with the University of Arizona's core values of a diverse and inclusive community, we recognize and acknowledge the people, culture, and history that make up our community. And at an institutional level, we are working very hard and proactively to broaden awareness throughout campus to ensure that our students, staff, faculty, and guests feel and are represented and valued. So while we continue to be unable to be shoulder to shoulder in lecture halls and exhibition spaces, we are continuing to gather creative and critical thinkers and makers from nearby, right here at home, as well as from places far away, to share their thoughts and work with our spatially distributed community. Before introducing today's speakers, I want to inform you about a few upcoming events, and you should be looking out for a semester poster in the coming days. Next Friday, on January 29th at 4:30, we are hosting a panel discussion that brings together 5 School of Architecture alumni whose post-graduation trajectories span 2 to 10 years and have taken them to work in a diversity of firms, specializations, and allied fields, as well as to earn master's degrees and be candidates in doctoral studies. So we hope that you'll join us for that lively conversation with our alumni. At noon on February 5th, School of Landscape Architecture alumnus Allison Kennedy will give a talk titled "The Past Isn't Past: Historic Preservation in the National Parks." And the last of these first series of talks at 4:30 on the 17th of September, Assistant Professor of Architecture, Altaf Engineer, will speak on synergies between research, practice, and education in health and the built environment. There will be many other exciting events this semester, including the ARCC, or Architecture Research Centers Consortium 2021 Conference on Performative Environments, which we're hosting April 7th through 10th. As always, you can find more information about these events and their speakers and links to register for them at capla.arizona.edu and under the news and events menu. So I want to now introduce this afternoon's lecture by Dr. Kristina Currans, titled "Ubiquitously Incremental and Pernicious." I love that title, that's terrific. "The Dynamic Role of Parking Supply in Increasing Vehicle Use." So Dr. Kristina Currans is an assistant professor of urban planning in the College of Architecture, Planning, and Landscape Architecture at the U of A, and she holds a doctorate in civil engineering. In her research, Currans explores the intersection between travel behavior and land development, between transportation planning and engineering. She aims to understand why, where, and how people do activities through space and time, and how that knowledge can be translated in practical ways that help cities build towards their communities' goals and objectives. So with that, I welcome Kristina and looking forward to your talk, and take it away.
Thank you, Beth. Well, welcome everybody, and thank you for joining me this afternoon. I am shocked that we got so many people during happy hour to join us to talk about parking. This is often a topic I feel like I rant about to people, whether or not they're interested in hearing more about what I have to say on this. But I'm glad to share these things with you all. I notice there are quite a few students in the room. I think this is an area where there's a lot of opportunity for research, for class projects, and so on. So if this inspires you or interests you at all, don't hesitate to reach out. There's plenty of work in this area to go around for sure. Let's see. So as Beth introduced a little bit of me and my background, I think one of the more important things to touch on here is I am an assistant professor in urban planning, but my background is really civil engineering. And the intersection between those two disciplines is an intersection that is really, there's a dearth of information. Engineers operate within a silo. Transportation planners sort of take what engineers are telling them for granted. And a lot of my work is trying to bridge those two gaps so that planners can have a bigger say in what's happening in their environment, and so that engineers can understand that what they are doing is not unbiased, and it has very clear implications for what happens in our built environment. So that's really the core mission of a lot of what I work on and what I do. As for this presentation, I'm going to try and keep it concise, because if you gave me 8 hours, I could easily fill 8 hours of time talking about this. I'm going to cover an overview of what transportation impact analyses are. It's a term that mostly engineers do TIAs, but planners often review them, and it impacts the way that buildings get built and the environment gets shaped. I'll talk a little bit about some of the criticisms and concerns in this area. There are more concerns than we have time to cover today, so I'll cover some of the high level and some of the big things we've sort of learned and noticed. And then I'll get into parking, where exactly parking fits into all of this, and the answer is largely it hasn't really in the past. It should, but it hasn't. Then we'll have a brief discussion, sort of bringing this back to some of the themes of the lecture series, and really ask the question, are TIAs really accurate assessments? What is their role and what are they doing to our built environment? Before I get going, I also want to acknowledge my many collaborators in this area. I'm going to be talking about several different studies that I've done over the past 10 years. I've worked with quite a few people. These are some of my more substantive collaborators. I want to acknowledge Nicole Rosalardo, who's in urban planning at CAPLA, as well as student Irene Pineda in landscape architecture, who might be on the call. She's working on our current project. So to provide an overview of what transportation impact analyses are, they are the method, one of the main methods that we use to evaluate the transportation impacts of land use development. So when you have a permit for a new development, whether it's a small shopping center, a residential development, an office development, a large big box store, or a convenience market, in many cases, in many agencies, it requires some degree of a transportation impact analyses, a study, an assessment, something of that nature. The point of TIAs is to evaluate whether or not new development is going to diminish the performance of transportation facilities. And there are two really important Supreme Court cases, Nolan and Dolan, that require us to do this to some degree. A rough proportionality that provides a nexus between that land use development and the corresponding impacts. So there is some legal standard for needing TIAs, but there's really no legal standard for what goes into one. So this sort of TIA area ended up being developed mainly by engineers in the 1950s and 60s, and it hasn't really evolved since then. For those of you who are familiar with travel demand modeling, TIAs are analogous to a 4-step model, but much, much worse. So related, but not really related. And the purpose of these developments is really to take the size of the development, to estimate the amount of vehicle trips coming and going from the site, and then to evaluate the adjacent facilities. So in this TIA process, there are several different steps. The first part is scoping, figuring out what your development is going to be, whatever you're preparing it to be. You evaluate the current performance of the facilities, how many cars are traveling around your area. You evaluate how much growth that new development might contribute to the facilities. And then you assess that additional growth on your facility. So you do sort of a before and after study related to how much vehicle traffic you're adding. In my work, I really focus on demand. I really focus on how we estimate how much more vehicle traffic or activity will happen at a site. So how many people are going to be coming to your office building? How many people are going to be living in your residential building? How frequently are customers going to be coming to your convenience market? Things like that. The reason why I focus on that area is because that is the first step of figuring out this impact. And it's often full of error and bias, which is why I'm particularly interested in it. So for this presentation, we're really focusing on demand, figuring out for a new development, what sort of trips is it going to generate for people, for vehicles, by different modes, for transit, for walking, for biking, and so on. So in this process, there's, I think I mentioned that a lot of these methods were developed in the 50s and 60s. They haven't really evolved in the last 50 or 60 years. But in the last 10 to 15 years or so, a lot of work has been done in this area. And most of that work has really been poking holes in the methods, pointing out problems with the data. For example, the data until 4 years ago could be upwards of 60 years old. Should we be using 60-year-old data to assess facilities? Probably not. A lot has changed in 50 years, especially related to technology, transit, modes, and so on. So before we get too far into the criticisms, I should mention that the state of the practice is really one specific resource. It's the Institute of Transportation Engineers Trip Generation Manual. And by and large, what this manual provides is estimates of trips, vehicle trips demand by the land use or the size of land use. It is heavily suburban. It is almost entirely automobile oriented. There are very few data points from urban areas or multimodal data, and most of that data are from research studies, like the things that I've worked on. And there's very little information about the sites that they include. So it's sort of like a black box, but it's like a black box of rates that don't have much more information than just X and Y coordinates. It's there's not a lot there. There's not a lot to work with. I wanted to show you an example of what this data looks like because it sounds more complicated than it is. It's actually probably oversimplifying everything that we do as travel behavior analysts. The example that I'm providing on the right is for a shopping center. In this graphic, we have an x-axis that provides the size of the development, and then a y-axis that estimates the average trip ins. So an analyst who's putting in a 1,000, and 1,000 square foot, so maybe 100,000 or 1,000,000 square foot shopping center would simply find the point in which the line crosses that size, and they would estimate the number of trips. That's all they do to estimate demand. Part of the issue with this is that it's very suburban. You have no idea where these data points are. For some land uses, the data points are all collected in Montana or Michigan, which might not be applicable to Arizona or California or wherever you're studying. In this case, a lot of the data is older than 1980, and shopping centers and how shopping centers operate have changed quite a bit. I mean, just during the pandemic, we've seen curbside pickup really take hold where we hadn't seen that before. That's a trend that's probably going to stick around for a while. So in this trip and parking generation data, it's really an oversimplistic, off-the-shelf way of estimating demand real quick and easy. But as we'll see in some of my examples below, these rates are not easily adjusted. We don't really know what's in there. And it's probably the quickest part of a TIA, and yet very little effort goes into it, even though behavior is kind of a hard thing to measure and to understand. So for one example of this criticism of having very suburban oriented data, I have one example here where I used ITE to estimate vehicle demand for a handful of different land uses. Those are the dark circle points. And we see that consistently ITE overestimates the vehicle demand in urban areas. And that means that if a shopping center goes in downtown Tucson, it means that it's going to overestimate the number of vehicle trips that will happen in and around that site. And they will overestimate what needs to accommodate that. They'll add extra vehicle turning bays. They might require a new, vehicle signal. In some parts of the country, agencies require roadway widenings, which means every time you put in a new development, automatically widens the roadway, whether or not it's needed, or whether or not these rates are accurate. In this example, I had created some basic urban adjustments, not very rigorous, but rough, and found that even with really simple urban adjustments, we improve the accuracy and our bias circles around 0, which is kind of what we want, where some sites might overestimate, some sites might underestimate, but by and large, our error, our bias is reduced. But there are a number of other issues with TIAs that I think we should generally be aware of before we start talking about parking. In a sense of coordinating and planning for different spatial scales, many cities, many metropolitan areas have some fairly strong land use and transportation planning at a regional level, sometimes at a city or a neighborhood level. But once you start getting down into that site level, there's very little holding the engineers and developers accountable to making sure that that site level planning tracks back to what your regional and citywide, neighborhood-wide goals are. That because ITE is this sort of off-the-shelf approach with very little sensitivity to the things we kind of care about, they're just estimating and evaluating and providing. In practice, that's called predict and provide. You're not thinking about it. You don't really care what comes out of it. You're assuming that you're unbiased because you're not thinking about it. So you're just predicting, providing, and moving on. One of our arguments, and for my collaborators in the work that we do, argue that actually these TIAs, or whatever site level assessment you do, needs to have really strong ties back to the regional plan. Otherwise, every time you build a new development, you incrementally get off target. You move slightly further away from what your goal is. And you might not even notice. It might be something that it just feels like you're 10% off. It's not going to really matter. But if every site is 10% off, you're not really thinking in terms of moving towards your regional goals, your city goals, and so on. And I think, thinking about travel behavior in general, ITE's approach ignores humans. We talk about vehicles, we talk about the size of the development. We don't mention who is the traveler, where they're traveling, the market demographics, what they care about, where are your goals in terms of mode share, in terms of safety, and so on. And so one argument against TIAs or towards a more equitable and fair process for evaluating TIAs is really taking 2 steps back and starting by thinking about people. So ignoring vehicles for a second, ignoring transit, ignoring everything, and starting with the people and how they would like to travel and really what they want to do in terms of their planning goals. And I think that's a really important part of sort of thinking through, well, where do we go next? Largely because I've spent the last 10 years working on improving some of the methods, but, in general, we can improve these methods as much as we want, but we're still starting from a place of thinking of vehicles. And we really should be starting from a place about thinking about people and, regional comprehensive goals that we want to try and move towards to achieve. So, I haven't even mentioned parking yet. This is really about parking. So where does parking fit into any of this? Well, the short answer is off-street parking, the parking that developments provide, is really one of the most neglected elements in transportation impact analysis research and just studies at large. Parking generation, estimating parking on site does not play into what we're thinking about when we're thinking about estimating transportation impacts. And my argument is this is one of the biggest gaps in this area, in this field, one of many, but in my mind, one that we should be able to address or start to bring in with the data and methods that we have available. So I wanted to walk through first some of the, frameworks for how I think about parking and how it plays into travel behavior. And then I'll show you some findings from a handful of different studies that have attempted to do this in different ways to start to address some of the questions that we have. So to start, one of the first things we did is we went to the literature and we did a comprehensive literature review, and we tried to map out the pathways between off-street parking and vehicle use. And in short, it was really messy. Before we get in, I thought I should distinguish a few things. Trip generation measures vehicle use. Those are the number of vehicle trips generated from a site, meaning the number of vehicles coming and going from a site. In general, that data not very multimodal, not very urban in nature. And the measurement that we're using is basically vehicle trips per dwelling, vehicle trips per square foot, things like that. Parking generation is vehicle ownership. We're really only thinking about demand. We're not thinking about supply. And so we're trying to measure parked cars per dwelling, parked cars per square foot, something like that. One of the issues with parking generations is that it's really often used to develop parking minimums. And the problem is both parking generation and trip generation, the methods have specifically been developed to measure the worst case vehicle use, the worst case vehicle ownership. So here we have the worst case vehicle measurement, and many cities for a very long time have been using those as parking minimums for new development that goes in. Another important thing to know is that these two data sets are separate. You wouldn't think they would be because they're often the same people collecting it. They're often at the same sites, but we have no way of connecting the rates in one book to the rates in the other. We assume they're related, but in all reality, they're not. And there's no way to tie the two of them together. For example, several cities have recognized that this is an area where they're pretty concerned about the worst case vehicle parking rates, and we're using them as minimums, means that we might be doing something fairly inefficient. And over again, we're finding consistently that 26 to about 44% of residential parking is unused. So we are asking developers to provide somewhere around 2 spaces per dwelling unit, and about a quarter to almost half unused. That's just dead parking spaces that, isn't really being used. Some of these studies have collected across their environments, and they found lower parking utilization rates near transit, higher densities. This largely means that people are finding other things to do to get around. They're not necessarily relying on owning 2 vehicles to do what they need to do. But this question still becomes, how does parking influence vehicle use? If you're to increase parking, or if you were to constrain parking, what does that do in terms of reducing vehicle use and therefore reducing greenhouse gases, reducing transportation costs, increasing transit use, and so on. So the first thing we did was a big literature review, and it was a nightmare. It was a mess. It was almost impossible. We thought there's no way we're going to be able to link parking to travel behavior with the 400 something studies we looked at. But the more we worked at it and the more we talked with professionals, we were able to start to see patterns, and we found a couple theories that actually really made sense with other parking related studies we had mentioned. And we developed this, a framework and conceptual map for linking off-street parking supply with vehicle use. And even as simplified as this is, it's still fairly complex. One of the things we argued in our paper, which is still in copy editing for some reason, but email me if you want a copy, was that off-street parking requirements, along with other types of parking measures and strategies, were really part of the built environment in a way that they influenced the costs of travel. And by costs of travel, in travel behavior research, we're really talking about a variety of short-term and long-term costs. So variable costs are things like how long it takes you to get to work, how much you have to pay in gas every month, whereas fixed travel costs are often more of the long-term decisions like buying a parking permit, paying for a car or leasing a car, deciding where you want to live, and how far you want to commute. And through these travel costs are where parking influenced vehicle use. So by constraining parking in different contexts, we might be making it more expensive to own a vehicle. And if we're making it more expensive to own a vehicle, we're also making it more expensive to use that vehicle. Across all of this, we have the role of socio-demographics. Socio-demographics plays a role in everything. It plays a role in where you decide to live, whether you decide to live in an apartment with only one parking space or two, or maybe an area where it requires you to buy a permit. It plays a role in how you see the travel costs and whether those costs are too expensive or affordable for you. And it also plays a role in how you use your vehicle in general. The money that you have to burn, but also, do you have kids? If you have kids, you might need to travel more. I think it was Eric Poss that said there is no characteristic of a household more impactful of your vehicle use than having kids. You're just gonna need to get around more, drive them places, go to the doctor more, and so on. So through this framework, we were able to look at parking in a number of different ways that allowed us to see parking through the lens of theory in a way that hadn't really happened in practice. So early on, when we were talking about, okay, well, if we want parking to be a policy lever, if we want parking and we know it plays a role in how you use your vehicle, we also want to have a sense of what outcomes we might expect so we can make sure we can look across those outcomes. So what happens when you constrain parking? Well, assuming you have a supportive network of alternative like transit, walking, easily bikeable, and adequate destination accessibility, which is basically the density of things around you. Do you have a lot of coffee shops? Do you have a lot of potential jobs? Do you have a grocery store near you? Things like that. Well, there are several different outcomes. One is that we might see fewer vehicle trips. So thinking about TIAs specifically, we might see people coming and going less frequently by vehicle. And that might result in longer trip chains. Trip chains are the series of trips that we do when we leave our home. So I don't just go to work, I go to a coffee shop and then go to work. And when I come home, I stop by the grocery store before I come home. That would be a trip chain. And when we constrain the built environment, when we increase travel costs, we also tend to see more trip chaining. We see people doing more things when they're out because they're already spending that money, they're already spending that time, so it's easier to do their errand when they're out. That could mean that even though we see fewer vehicle trips, people might be driving just as much or even more. They might just be doing more things for every one trip. So another outcome we're really interested in is whether or not we see less vehicle use overall. And the vehicle use measure we tend to use is called vehicle miles traveled. With measurement for your household of the total miles that you travel or your household travels in a vehicle. So even if we see fewer vehicle trips from within that development, by constraining parking, we might actually see overall less vehicle travel, which means that regionally, you might be contributing less greenhouse gases, for example, or you might be paying less in fuel, for example. So in one study, we specifically focused on looking at that vehicle trip question. Are we seeing fewer vehicle trips at development with constrained parking? And the answer was, yeah, we are. And it's significant and pretty highly significant. So in this study, we're looking at residential housing, specifically subsidized affordable housing in LA and the Bay Area. We're controlling for things like demographics, built environment, development characteristics. So we know that, a development with all 4-bedroom dwellings is very different than a development with all studio apartments. So we're controlling for that. And we're just looking at that relationship between the parking spaces for each dwelling unit and the amount of auto trips that they're generating. So on the two graphics on the right, we're focusing on the parking ratio, which is the number of spaces you have per dwelling unit. So the average number of spaces that you, as a resident in a dwelling in affordable subsidized housing, have, and the number of vehicle trips you're generating to and from the site. And for both the morning and the evening, we're seeing that the difference between an apartment that has 2 spaces per dwelling unit and an apartment that has 1 is pretty substantial. So in the PM peak period, which is often the evening peak period, which is often the period we care more about in travel, we see that apartments with like 2 spaces per unit generate almost like 60 something trips more than apartments with only 1 space per unit. And this is a pretty significant difference when you're thinking about, if 50, 100 unit apartments go into your city, that's a pretty significant difference in the total number of vehicle trips coming and going your site. I also added on here the elasticity. One measure that we like to talk about in travel behavior research is an economic metric, the elasticity. And it basically gives us the ability to compare this relationship between vehicle trips and parking spaces with other environments and characteristics. When we're looking at the relationship between vehicle travel and density, for example, that elasticity varies quite a bit, but it's not nearly as big a difference here. So here we see that on a regional level for subsidized affordable housing units, for every 1% increase in parking spaces we provide per dwelling on the aggregate, we would expect a 0.7 to 0.8% increase in vehicle trips. And that's considered an elastic relationship. There is a response there, and it's noticeable. So that was a pretty important finding here that basically said that, yeah, constraining parking, controlling for all the things we don't normally control for, demographics, development, environment, that this relationship does exist and it's pretty substantial. Similarly, we started thinking, well, maybe these residents are more or less trip chaining more. And so their overall vehicle impact might be a lot higher, even though the vehicle trips are diminishing. So we have this other study that we did where we looked at the overall vehicle use for households. So in this case, we're focusing on the total vehicle miles traveled across households. Here we're looking specifically in LA We used a household travel survey that was completed by, it's a national survey, but it was completed and expanded within the state of California. And we linked that data with parking supply. Now, specifically in this study, we had, thousands of data observations, thousands of households. So we were able to do a little bit more analysis, and we learned that, that ratio between parking supply per dwelling unit, that continuous measure we had measured before, there's actually kind of a threshold. And that threshold is right around 1 space per dwelling unit. That anything above that is fairly unconstrained and not noticeably different. And everything below that has a noticeable boop effect on the vehicle travel. So what we're seeing here is a scenario analysis that we did using all the models and all the technical work that we did. And we wanted to compare all of these different contexts and parking situations with suburbia, because ITE's data is representative of unconstrained parking in suburban areas. So all of these other neighborhoods, urban neighborhood, urban district, urban core, are estimated relative to suburbia. And what we found was that constraining parking, just lowering parking enough for about 1 space per dwelling unit, we saw about a 10 percentage point decrease in total vehicle miles traveled, the overall use of the household vehicle in all of these contexts. So that was a pretty significant finding for us, because it indicated that, first we identified that vehicle trips seem to go down when we constrain parking. But here it shows that, well, actually, people aren't making longer trips corresponding to that. It's sort of leveraging these built environments that are more dense with other opportunities. And overall, there's a pretty substantial decline in the total vehicle use. So that was a great lesson to learn overall. And in this case, we're expanding this analysis to other California cities as part of a longer project aimed at this question. So that brings us back to our potential outcomes. Now, there are a few other things that we might observe when we're thinking about taking away parking from people or not providing more parking. One is that we might start to see vehicle use shift off-site. So within transportation impact analyses, when you're estimating the amount of parking you have to provide for your development, if you stop providing parking, it doesn't mean that all the vehicle travel goes away. It could mean that some amount of vehicle travel is shifting to the neighborhood, to other parking garages, and so on. In TIA analysis, very few cities consider the larger impacts on a neighborhood or the characteristics of the neighborhood. So we were very curious, okay, well, if we looked at really constrained parking situations, does that mean that there are zero vehicles, or do we see something else? So in this example, we were looking at 12 sites in Portland, and we could only do 12 sites because if you've ever done this area, these are crazy expensive. They can cost anywhere from $6,000 to upwards of $50,000 to study one site, one development adequately. We picked 12 locations in Portland, Oregon. All of them had fairly good transit access, some better than others. All of them were pretty walkable. They had a lot of destinations around them. So these are all fairly urban locations. I removed the names in part because I don't think the names are going to matter to any of you, but also because it's a final report that hasn't been released yet or published. But I replaced them with the parking ratio. So this is how many parking spaces on average are provided per dwelling unit for each of these residential houses. The three on the left are all zero parking developments, which were all very controversial when they went into their neighborhood. And then moving up, we have all constrained parking developments, but some are constrained a little bit more than others. In what we're looking at here, we're estimating specifically vehicle trips, so we're still only thinking about vehicles. And this blue bar that we're seeing here is analogous to ITE. So the blue bar is measuring the number of vehicles, people in vehicles that crossed the cordon to the site. That's how ITE measures vehicle trips. Everything else, the orange, yellow, gray, are vehicle trips that are associated with the site, but those vehicle trips don't cross the cordon to the site. So all of this is the spillover vehicle impact that these developments had on their neighborhood. You'll notice that the zero parking developments still have some vehicle impacts associated with it. But overall, these 12 sites are relatively similar. It looks like there's a lot of variation, but in reality, there's not a whole lot. We could probably create some average rates based on these. It's also worth noting that these are all urban Portland sites. ITE's rates for vehicle trips are somewhere between 0.4 and 0.6. This scale goes to 0.3. So ITE for all of these sites, if you were to continue to use ITE's data for urban areas, are significantly overestimating the vehicle demand in all these sites. And I say that only because if you ever go to a city and they're using ITE and you're in an urban area and it's got transit, it's walkable, it's dense, you should collect your own data and decide whether or not you use it, because often you shouldn't in an urban area. If we're not shifting those vehicle trips offsite, the gold standard of all of this work is that, yay, we're putting those trips, those people into alternative modes. So in that Portland example, we also wanted to collect a lot of multimodal data. So here we have the same 12 sites. They're in the same order relative to their parking. But instead of mapping vehicle trips, we're actually looking at the total person trips. The blue is still that on-site vehicle demand. This is analogous to what ITE measures. The orange is still the shift of vehicle impacts into the neighborhood. And then everything else is walking, biking, scooting, transit, rideshare, car share. The most noticeable impact you might see is this gray. Those are all walk trips. All of those are walk trips. And yet in most TIA, we ignore walking. We assume, oh, we'll add a sidewalk, it's perfectly fine. But by and large, in many different contexts, including when we look at suburban areas, we see a lot more walking than we expect. In this case, this is evening data. So it's likely that some of these walk trips were actually transit, and the people answering questions maybe didn't understand when we asked them, are you sure you didn't take transit? We see that a lot in this kind of work. But overall, we see, even though we have this shift of parking to the adjacent neighborhood, we do see a sort of successful amount of walk trips around there, which is usually a function of constrained parking as well as the supportive environment, accessibility, and other things like that. I also wanted to throw this out. I have any opportunity to poke a hole at ITE. ITE's suburban sort of baseline data assumes 5% of trips are walking, biking, and transit. 5%. So if you're applying that data in urban areas, you're ignoring a substantial amount of walking activity, of biking, of all the other modes, and sort of pretending that it's negligible because your suburban ITE has not seen it. There is one more outcome, and I wanted to mention it in part because we have a lot of students here. It's possible that when you start constraining parking, you start to see fewer trips taken. You start to see people doing less activity overall. Sometimes it's a good thing. Sometimes it means people are telecommuting. So you wouldn't see as many commute trips if people are telecommuting more. But there's also some fairly large equity issues where if you're constraining parking, what you might be doing is just making it more expensive to live and to travel around your area. And in my opinion, this is an area where there's not a lot of research. A lot of people are thinking about this, but we don't have any answers. So for those students who are really interested in sort of thinking about a big gap out there, in my mind, a big gap is, how do we start to measure? How do we ask people about things that they want to do but can't? Because most people don't think that way. You couldn't ask them, were you able to go to the grocery store every time you wanted to go to get food? People don't think in the way that I think we do as sort of academics and transportation professionals. So huge area of research for those that are interested. But this got me thinking as I sort of wrap up this presentation on when Beth asked for presenters to start this off, the theme, at least at the time, was sort of performative environments. In this approach, we're really evaluating the performance of the environments. The environments are supposed to be performing for us, and we're evaluating that as transportation engineers and planners. But are we really accurately evaluating what these impacts are and sort of doing the environment service? Thinking about the title, these are three words that I often use to describe TIA: ubiquitous, incremental, and pernicious. It's ubiquitous because it's the industry standard. If you sampled, 100 cities across the US, the likelihood that they would be applying this data and this method is probably around 90 to 95%. Only really large cities with technical expertise are changing it up and doing something different. It's incremental because it doesn't seem like it matters much. It's one development here, it's one development there. But every time you do it, it's that much more. It sort of chips away at what we know and what we're mitigating, what we're changing in our environment. And it's pernicious because, especially in urban environments, we see time and time again that the ubiquitous industry standards are overestimating. So every time you have this development and it's a little bit off, it's also a little bit biased. And it's been that way since the 1950s, 1960s. When we think about how that sort of slowly chips away at our urban environment, little bit by little bit, when we have additional fees, additional mitigations, we see two major outcomes. One is that we keep adding little bits of automobile capacity. We widen the street slowly and slowly. But we also see that developers start to scale back their developments. If you tell a developer that their impacts are you're going to charge them $300,000 for a new traffic signal to accommodate all the vehicle traffic, they start to shave away at the housing that they provide or the type of development that they provide in a way that moves us away from our goals in terms of our zoning densities and really just what we think would thrive there. When we add additional automobile capacity, we see time and time again that induces demand. And that's true with parking. If we're adding additional parking, we're inducing people to buy cars. We're subsidizing it in some ways. We're inducing vehicle demand, but we're also lowering densities. We're removing some of that destination accessibility that we could be putting out there. And both of these outcomes, both of these tracks, lead to a more auto-dependent society. So, leaving this into discussion, I feel like I've probably ranted enough for a night. I really am asking myself and other professionals today, really, are we accurately assessing transportation impacts? Or are we just doing a performative exercise that pretends that we're doing that, overestimating things along the way? So I'll leave that there. Rant over for now. Let's see. I see we have a chat. I'm going to stop sharing my screen because I can't see it very well. I see Chris Nelson has a question.
Yes, Chris Nelson has a question. You've got some applause. So I'll, if I can get my chat back up. Here we go. Yes, so Chris Nelson, as we approach a driverless world, are there insights about planning for this future that we can glean from research on parking demand associated with such ride-hailing services such as Lyft and Uber?
Yeah. So the Portland study that I mentioned, one of the other side of that I didn't talk about here was that we were trying to gather some rates of curb space usage related to not just Uber and Lyft, but delivery services. And this was pre-pandemic. So we were measuring fairly low rates, and we've seen those rates go up substantially. I think one of the challenges with TIAs is that we need to be able to think more flexibly about how we use space. And specifically, that's related to our curb space. So I would argue that we definitely don't need as much parking as we've been providing. But I think what we've seen in this frame of mind, that will be another area that I think is developing right now, is really thinking about how and when we use public spaces like the curb and the sidewalk, and whether or not we're also subsidizing those spaces for other companies. So I think there's a public policy discussion that's sort of brewing that I don't know, maybe I'll have to write that paper, but we're seeing in cities, really some of the people benefiting a lot from sidewalks are Amazon, and some of these delivery companies that are not necessarily, they don't necessarily have good reputations for how they treat their workers, but they're using some public space, e-scooter companies, other forms of micro-mobility, and they're not always sort of paying back into the system. They're benefiting from it. Their business model depends on it, but they're not necessarily gaining more. So I think beyond this realm, there's a larger question about shared public space that probably needs to play into this. I see Jonathan and then Bill.
Sure. So Christy, I was wondering, the city of Tucson right now is undertaking a process to try to change some of the policy to make development of ADUs or additional dwelling units more friendly or easier or just better, I guess. I maybe none of those words are exactly describing what the intention is, but to formalize the policy for ADUs. And of course, parking becomes this like bogeyman in the room, right? Where everyone's afraid that they're no longer going to be able to park in their neighborhood because of development. And how, based on what you've learned, how would you go about sort of pointing out the or sort of changing the direction in the course of that conversation to point out some of the costs of the current oversupply of parking rather than the fear of not having enough?
Right. So most of my work has been in sort of Portland, San Francisco, LA, where they actually have competitive on-street parking issues. The ADU really comes down to being an issue of affordability, that ADUs to some degree make a really strong argument for housing supply and getting housing supply in areas that already have supportive infrastructure. And I think that, that fear of, shifting those things to parking could probably be mitigated by thinking about sort of transit subsidies or TDM subsidies, where you sort of encourage residents in those entities to think about other modes, as well as just measuring parking. I think, one of the issues of integrating this into travel behavior research, very few people do. And they often make the argument that, oh, it's correlated with the built environment. Therefore, if we know density, we know parking. We found in our work that that's 100% not true. And I've, been pushing for finding ways to just measure available parking, and not just available parking, but utilization. Because I think that those fears are often in neighborhoods where when you visit them, especially in Tucson, there's like not a car parked on the street. Everybody not only has a driveway, but they've got like enough space for 3 cars, or, and then occasionally somebody's parked on the drive, in the road. And I think when you start to look at those numbers, you realize, our problem is not bad at all. This is just a perceived fear that I think more and more there are discussions about equity in a way where I kind of think that that's shifting the blame into a perceived problem that's not very real, because really what they're afraid of is who's going to live in the ADUs and who exactly, specifically related to demographics and what that does. So I do think that there's some degree of like, they're not actually concerned about parking, but they're using that because that's an easy thing for people to complain about. So collecting that data, and it could just be photos, like what parking problems are you, if every fourth house has an ADU and there's nobody parked on the streets, I think it's going to be negligible. This is not going to be a significant effect. But that's what I think about that. And in Portland, they did have an ADU policy, and it was so strongly tied to equity and affordable housing that I think that kind of shut a lot of people up, because, when you realize housing is tight and expensive for a lot of people, it's a hard thing to argue with too. Bill?
Great presentation, thanks.
Okay.
So how are you going to add like class or demographics or lifestyle and how that all fits within this? Because you could do a 16-unit apartment building in one location of town at a certain cost, and a 16-unit apartment building in another location in town, and another location, and you could have varying parking realities associated with all of those depending on race, class, ethnicity, whatever.
Oh yeah. Yeah. So traditionally TIAs, in the sort of historic sort of nature of engineers, we have ignored it in a sense, because the argument has been, well, demographics change, therefore we don't want to introduce that error. I have a feeling that a lot of the data that was collected, just by my knowledge of the data that I've seen, is probably collected in majority white, majority higher income areas, because those are the areas where the neighborhoods complain more historically. Just my knowing that, most of the engineers are higher educated, higher income, who work on this data. In our work, one of the things where we've started to chip away at that is started to control for those things. We sort of pull out the income effect, because I do think that if you're collecting data in those incomes, one thing you are showing is that if you want to put housing into low income neighborhood, but you're using high income vehicle rates, it looks like your impacts are going to be massive, but they're probably not in some ways, because vehicle ownership rates are lower, or, the built environment is lower and things like that. So we've been trying to control for that, just to show that just looking at the rates related to parking tend to be lower even in suburban areas, and that's probably that income effect. I think in terms of an area of future work, I think we need to grapple with that. And from an engineering perspective, I think one of the big limitations and inhibiting things about engineers is we think we're unbiased. We're not going to talk about income or race or class or ethnicity or any of that, therefore we're unbiased. But really it's embedded so deeply in these specific data and methods. I think we need to lean really hard into that and figure out how we control for that, because I do think that we've probably seen development at higher rates be NIMBY'd, so not in my backyard, prevented in some areas because of this issue specifically, because we're pretending to be unbiased, but actually we're sort of ignoring some really important parts of travel behavior. That's a good point. And for any students looking for a project, another great thing to think about. Bill, did you have another? No?
Nathan had a question. What are your thoughts on building infrastructure and planning development around transportation ahead of commercial residential projects?
Yeah, so there are different streams of thoughts when you're thinking about transportation and land use concurrent development. Several states actually have concurrency laws, which requires in different ways that transportation and development happen concurrently. In states like Florida, you can't build transportation unless you are sure that development will happen within 3 years. Whereas areas like Oregon and in Washington, it's a little more flexible, but how it works, but it's actually prevented a lot of development from happening because transportation development is so much slower. So in my mind, when you're thinking about planning, specifically planning, not necessarily the actual development, you really want to think about what's called build out. And build out is where you look at your land use plan and you look at what legally the densities and the land uses that you're legally able to kind of build to or allow people to build to. And then walk back, okay, in that world, what should our transportation environment look like? And once you have that sense, that sort of 30, 50-year build out sense, which is probably longer than 50 years because development doesn't happen that quickly, then walking back and thinking, okay, if we were incrementally building in that way, our transportation or land use in that way towards that future, what should that look like? We don't really do that right now. We often do our transportation plans fairly separate from our land use plans. Some models have those ties together, but they're not really. So in my mind, especially with related to TIAs, that's the type of framework that me and another colleague are trying to develop. Okay, well, how do you do that somewhat analytically so that you're legally, you do the steps you need to do to legally show how you're sort of why you're requiring certain things. But it's not such a one-off. It's much more closely tied together. But that's a great question, Nathan.
Last call for questions.
All right.
Let's thank Christine for a really super informative, brilliantly researched talk. And have a wonderful Friday, everybody, and come back next week to hear what some of our wonderful alumni have been doing since their time since graduation. Have a fantastic, safe, and healthy weekend.
Yeah, thank you, Beth. Happy hour, happy hour.
Thank you so much.
Bye.